Hi, my name is Cody Leveille, and in this code review, I'll be walking through one of my earlier artifacts and explaining how I plan to enhance it for my CS499 portfolio. The artifact I'm using is a Java Swing application that displays a top 5 destination slideshow. In this review, I will describe what my code currently does. I will analyze it using a professional code review checklist. I'm going to point out weaknesses and limitations in areas like structure, commenting, and robustness, and then I will explain how I plan to enhance it into a full stack web application that demonstrates the three core principles of the CS 499. Those are software engineering and design, algorithms and data structures, and the use of databases. I will structure this review into three categories that match the CS 499 requirements. Category 1 will focus on software engineering and design. Category 2 will focus on algorithms and data structures. Category 3 will focus on the databases, and for each category, I'll connect my planned enhancements to the CS 499 course outcomes. Now I am starting Category 1, which focuses on software engineering and design. First, I'll describe what the existing code does and how the slideshow works. The artifact is a Java Swing desktop GUI, or a graphical user interface. When I run it, it opens a JFrame window titled Top 5 Destination Slideshow. It displays one slide at a time with an image and text description. Navigation through the slideshow currently happens with the previous and next button, labeled here. Through these, the slideshow is able to cycle back and forth between the previous slides. The overall interface for the user is set up through the constructor here init component. The slideshow uses two card layouts, one for images and one for text. Seen here, slide pane.setLayout card text pane.setLayout card text. A loop is run through 1 through 5 to determine which slide is being used. The previous and next buttons call methods that switch the card layouts. So overall, this is a simple slideshow that cycles through 5 hard-coded destinations. Next, I'm going to review the code using a professional code review checklist. Currently in this Java application, it uses proper naming conventions such as camel case and proper class naming throughout. If you scroll down to the main function, it also utilizes the event queue.invokeLater properly. Scrolling through the program, you can see that proper indentation is used throughout. However, with everything being within this one program, it is monolithic. The init component method currently does too many things all inside one place. First, it handles the frame setup, like setting the size, title, and layout. The size is set here, the title is set here, and then the layout is set here. It also sets up the layout and panels, which should be really handled in their own method. Then, it creates all of the slides inside of a loop, which should be their own responsibility. Currently, this method sets up the buttons and their own event listeners, which really belongs in their own methods. In reality, this one method is handling the job of 4 or 5 different methods. It should be broken up into these methods that are more direct, more precise, and more informative for users to look onto. This program has numerous magic numbers, as someone would call it. They're just hard-coded values that need to be changed. For example, the set size. The 800 by 600 is hard-coded into the program to set the size of the slideshow with no real reason, followed by the loop that utilizes only 5 slides in total. The slideshow can be adapted to many different needs to allow a user to input their own number of slides rather than just hard coding 5. This program does utilize all of its methods throughout. The init component handles the bulk of the operations, while other smaller methods handle the overall functionality of the buttons and the overall structure of the slide. The program does utilize repetition that is completely unnecessary. The get text description and get resize icon currently cycles through based on what value the previous loop utilizes. Without the utilization of data structures, this is necessary, but by making the slide itself its own data structure, you can eliminate these two entirely. Overall, this code does work, but it's tightly coupled and is not scalable. The overall documentation in this program are minimal. Some comments are outdated about notes and they need to be changed. Some comments such as create the application is very vague and doesn't really convey much. The initialize the contents of the frame are helpful. Functionality of the buttons are helpful. When it comes to the contents of the get resize icons, it has comments such as change image to reflect change. It's very indecisive and doesn't really explain much. Then you go to the get text description. The comments here are more reflecting on what was done within the HTML code of the actual slide. Change title and description to reflect new places. Also change color of text to make it easier on eyes. This shows that the image was changed and the text was changed and the color was changed. A simple, more concise comment would be more useful. This is a common trend throughout all of these sections throughout the program. Throughout the program, the variables are named properly for the most part. One issue that I do have is the J label named label text area. This can cause confusion for anyone reading or maintaining the code because the name implies a completely different swing component type. If another developer saw the name, they might assume it's a multi-line editing, cursor input, or scrolling, all behaviors of a JText area, which could lead to an incorrect assumption about the UI. A clearer name for this component would be label description or description label, which describes the actual purpose, showing the text description for each slide. Good naming matters because it enforces readability and maintainability. When you work in a team with multiple people, it is vital to name these things properly so there isn't confusion down later on in the development process that can lead to bugs or larger project problems. The overall variables are used throughout the program properly. There are no unused variables, which is good. Some variables do not need class-wide scope, though. For example, JLabel, label slide, and JLabel, label text area are only used within the loop, which they are redeclared each time they are reiterated. So these are not necessary in this location. The overall arithmetic within this program is minimal. Just frame sizes, loops counters, and no complex operations. The main loop is simple and correct. It handles all cases. The else-if chains cover all cases as well. But there's no default case within this program. With no default case, there's no fallback handling. A good design would have this within the program to avoid issues. For defensive programming, this program is very low risk. There is no external input, no file or network access, and the hard-coded values need little validation. This does not demonstrate good defensive coding, but its minimalistic design is its strongest asset. Here's what needs to be improvement: the tight coupling, magic numbers, repetition, weak documentation, and a minimal defense design. Currently, this program uses one method to handle the bulk of its logic. The first enhancement I want to do is I want to break down any component into multiple smaller methods to handle this logic independently rather than all at once. There are magic numbers throughout the program that need to be changed. The set size, 800 by 600 pixels, need to be changed to allow users to change the overall slideshow size based on their device. The number also has to be changed from 5 to allow users to have as many slides as they wish. I want to rebuild this application within JavaScript utilizing Node.js, Express, MongoDB, and handlebars to handle the requests. The documentation throughout this program are lacking. I plan to implement clear, concise documentation showing users what is happening, what is functioning, and what each thing does. There is no error handling throughout this program. If something breaks, the program terminates. I want to have error handling, so if something were to go wrong, it's not going to just give you an error, improving programming security. These improvements, I believe, are in line with what is expected for CS 499 outcomes. This is the end of Category 1. I have analyzed the code, identified weaknesses, and planned improvements using software engineering principles. Next, I'll talk about Category 2, which focuses on algorithms and data structures. Right now, from an algorithm perspective, the slideshow is very simple and doesn't implement much logic. The only algorithm in the entire program is this for loop that runs from 1 to 5 and creates each slide. The program uses two helper methods, get resize icon and get text description, which rely on long if-else chains to return different strings for each slide. They are here. These chains utilize based on what iteration in the loop to display proper information, what image, what text, and everything in the slideshow. There's no actual data structures representing a destination. All the information is hard-coded inside of these methods and strings. So the slideshow logic is basically loop from 1 to 5, pick different strings throughout the conditionals, and show them in a card layout. It works, but it doesn't demonstrate a meaningful algorithm or data structure. The if-else chains are a form of manual dispatching. This means the program is manually selecting which block of code to use, instead of using a real collection like an array, list, or map. There's no way to compute the top 5 list based on any actual criteria. It is ordered just 1 through 5 and it is hard coded. Currently, there is no encapsulation of what a destination is. There's no fields like title, location, or rating. Everything is just embedded text. The approach makes a slideshow functional but extremely hard to extend. If I wanted to add 10 more destinations or let the user customize them, I would have to go into the system and manually rewrite each one and hard code them. So here are the opportunities for improvement in this category. First, I can introduce a destination data structure with clearly defined fields like ID, title, image name, country, tags, rating, and number of reviews. Next, instead of using long if-else chains, I can store these destination objects within a list or an array so the program can iterate over them naturally. Finally, I can implement a basic ranking algorithm to compute which destinations belong in the top 5. This could be based on ratings, user votes, or review counts. In my enhanced version, I'll create a real destination model in Node.js and MongoDB that represents each slide with structured data. I'll replace the if-else chains with an array or a list of destination objects, which is cleaner, scalable, and easier to maintain. I'll implement a simple ranking algorithm that computes a score for each destination using its ratings and numbers of reviews. I'll sort the list using something like array.sort, which has a time complexity of O n log n. This demonstrates algorithmic reasoning and an understanding of trade-offs. These enhancements align directly with Outcome 3, which involves designing and evaluating computing solutions using appropriate data structures and algorithms. So overall, the current artifact uses simple logic, but the enhanced version will demonstrate strong algorithm design and proper use of data structures through the destination model, collections, and ranking logic. Every destination's image reference and description is stored as a long string inside methods like get resize icon and get text description. As you can see, they are very unorganized and cluttered and excessively long. Because everything is hard coded, there is no persistence. When the program closes, all destination data disappears because it was never stored externally. There is no schema or structured format that defines what a destination actually is. There is no fields like title, rating, or country. So, from a database perspective, the current artifact is basically pre database. It relies completely on hard coded values inside the source code. One of the biggest limitations is that any change to the destinations require modifying of the source code and recoupling the entire application. If I wanted to add more destinations or let users choose their own, this structure wouldn't scale at all. Since the data isn't stored in a database, the program can't run queries like sorting, filtering, or selecting destinations based on user preferences. All the data is mixed directly into the presentation layer, which violates separation of concerns and makes maintenance harder. To improve the artifact in Category 3, I'll focus on separating data from the user interface and introducing persistent storage. The first major improvement will be creating a real destination schema that defines fields like title, image name, description, rating, and various tags. Instead of hard coding everything in Java, the enhanced version will store destinations in a MongoDB collection. Using MongoDB also allows me to add CRUD operations. Even if the slideshow initially uses read, the data will now be stored in a proper database. In my enhanced version, the Node.js backend will connect to MongoDB to retrieve all destinations. Using a destination model with defined fields ensures the data is structured, searchable, and consistent. I'll apply the ranking algorithm from Category 2 to the database results, selecting the top 5 destinations dynamically instead of hard coding them. I will also validate any data coming to the database, enforce field types in a schema, and use least privileged database user account for security. This enhancement supports Outcome 4 by using modern tools and technologies, and Outcome 5 by demonstrating secure, validated database backend design. So, in summary, the current artifact has no database and relies on hard coded values, but the enhanced version will use MongoDB with the destination schema, structured data, CRUD operations, and secure handling. This shows database integration and supports the overall goal of this project for CS 499. Before I move on to how the enhancements demonstrate the course outcomes, I want to briefly discuss some of the challenges I faced while working with the original artifact. One major challenge was the fact that all of the content is hard-coded. All of the images, HTML strings, and descriptions are embedded directly into the Java file. This makes the code difficult to update and prevents any kind of reuse or extensibility. Currently, the program is locked into 5 slides. There is no increasing or decreasing the value. Changing the number requires rewriting the loop, rewriting the if-else chains, and modifying multiple parts of the file in this design. As you can see here, all the logic happens within this one loop. Without changing this loop, other slides cannot be added to the slideshow. Another challenge was that everything lives in one class. UI logic, control flow, content generation, layout configuration, and event handling are all combined when everything is bundled together like this. It becomes much harder to test, maintain, and extend the system. Although functional, the use of the legacy graphical user interface technology is limiting in this program. This program utilizes JavaSwing, which is considered legacy. It still works, but is not very common to be used in modern industry-ready applications. That was a challenge because there were limits on how I could improve the user experience within the original UI framework. Another challenge that I came across while reconstructing this artifact is there's no clear separation of layers. There's no model, no controller, and no service layer. Everything is blended together, and this makes it very difficult to implement new features without redesigning or restructuring the entire application. Now, you might be asking yourself, why are these challenges important? Why should they be considered? What's the point of them? These challenges are what I initially considered when selecting an artifact for enhancement for my CS 499 capstone project. The program that I selected was one of the first ones I wrote within the SNHU CS program. The original design was simple and functional, yet had gaps that allowed me to highlight great opportunities for growth in software engineering, algorithms, and database development. Before I wrap up, I want to clearly explain how my planned enhancements connect to the CS 499 course outcomes. The enhancement plan isn't just technical, it's designed to show mastery of the program's key competencies. In regards to Outcome 1, my enhancements improve clarity through better structure and documentation. By reorganizing init component into smaller methods and adding meaningful comments, I am demonstrating professional communication through clarity. Comments such as create the application, initialize the contents of the frame, set up frame attributes, logic to add to the slides and text are meaningful, but they could be more concise. Comments such as change image to reflect change image to reflect change, on repeat multiple times is not very helpful and doesn't explain much. Same as here in this loop here. Change title and description to reflect new places, also change color to make text easier on eyes. Repeated several times is not useful commenting in a program. In regards to Outcome 2, even though this project is individual, the improvements promote team readiness, a modular structure, readable names, and strong documentation make the code easier for any developer to understand, modify, or extend. In regards to Outcome 3, this outcome is shown most strongly through my algorithmic design by creating a destination data structure, adding a ranking algorithm, and using proper collections. I'm demonstrating the ability to design, evaluate computing solutions based on algorithmic principles. Currently, with no data structure in this program, everything is created in the for loop. It runs through one simple loop and grabs hard-coded data to display the information for the slideshow. In get resize icon and get text description, it is hard-coded information that pulls an image, the color, and description from the source code itself. By implementing a data structure and utilizing the strengths of MongoDB, you can store everything within the database, and it can pull that information directly from the database and maintain saved information throughout sessions of the program. Outcome 4 is demonstrated through the shift from a desktop Swing app to a full stack Node.js application with Express, MongoDB, and handlebars. This shows my ability to use modern tools and frameworks and demonstrates the full stack development skills expected in this field. For Outcome 5, my enhancements incorporate security-focused practices. These practices are validation of input data, structured schema in MongoDB, least privileged database user accounts, clearer separation of concerns. These changes directly reinforce and enhance the secure coding and ethical handling of data. So overall, the enhanced version of this artifact will not only work better, it will demonstrate each of the CS 499 outcomes in a clear, intentional way. These enhancements elevate the artifact from a simple GUI project to a professional-grade full-stack example of my skills. That concludes my code review for CS 499. I walk through the existing functionality of the artifact, analyzed its weaknesses across software engineering, algorithms, and databases, and explained my enhancement plan for each category. These enhancements will allow me to demonstrate the CS499 outcomes in my final project.